Okay, so we're still doing 5.1, and we're doing prime and composite numbers. So if you remember, if I have 24, can I make 24 smaller? Well, 4 is even, so I can divide it by 2. 24 divided by 2 is 12. So this cannot get any smaller. Can I make 12 smaller? Yes, 2 times 6. Can I make 6 smaller? Yes, 2 times 3. Can I make 3 smaller? No. So all of these numbers that are circled, we call them prime numbers because we can't make them any smaller. These numbers here that I can make smaller, we call them composite numbers. So any number you can make smaller is called composite, and any number that stops and we cannot make it smaller is called prime. So if I take 3 and I want to say what times what is 3, well, the only answer is 1 and 3. Okay? And here, when I have a prime number, the only factors are 1 and itself. So whatever number is here, it has the same number down here, itself. Okay, so if I take 5, what are the factors of 5? Only 1 and 5. 1 and the number itself. So that's what a prime number is. And prime numbers have to be bigger than 1. Composite numbers just means you can have lots of factors. Prime, we only have 2 factors, but composite, there's lots of factors and they have to be greater than 1. So negative numbers are not composite and not prime. When we have 0 or 1, these are not composite and not prime, and we say, oh, they're neither. Okay, they're neither composite and they're neither prime. They're not composite, not prime. Okay, so so here I wrote out all the list of prime numbers less than 100, and you can see that 9, you can go 3 times 3 is 9, so you know it's composite. But 7, the only factors of 7 are 1 and 7, so you know it's prime. Okay, let's look at the next page. 11. Is 11 prime, composite, or neither? So 11, I can go, well, I can't go divide by 2. Maybe 3? No. 4? No. 5? No. 6? 7? I could keep going, but if I look at my little list, 11 is on the list as a prime number, so the only factors of 11 are 1 and itself, so we know it's prime. 18, I can divide it by 2. 2 times 9, so I know it's composite because I can break it down into something smaller. 27, if I go 2 plus 7, that equals 9, so I can divide this by 3. So 3 times 9 is 27, so it's composite because I can make it smaller. 47. 47 is on the list as a prime number, so I know that the only factors of 47 are 1 and 47, so I know it's a prime number. 0, too small. So 0 and 1 are too small, so they are neither. They're not prime and they're not composite. It's like going to a restaurant when you say, do you want fries or a salad? You go, ugh, neither. I want pizza. That means you don't want fries, you don't want salad. Okay? 136. Well, that's an even number. 0, 2, 4, 6, or 8. It's an even number, so I know I can divide it by 2 times something, which means I can make it smaller, so I know it's a composite number. I don't have to actually know what that number is. Okay. Same. 19. 19 is on the list as a prime number, so the only factors are 1 and 19 itself, so we know it's prime. 39. 3 is divided by 3, 9 divides by 3, so I can divide this by 3. Let me just check to make sure. 39 divided by 3. Yep, 13. So I know it's composite because I can make it smaller. 56. This is an even number, so I know I can divide it by 2. So I know it's composite. 1, too small. 0 and 1 are too small, so they're not prime, they're not composite. We say it's neither. 75. It ends in a 5, so that means I know I can divide by 5 by 5 times something is 75, so I know it's composite. 83. It's a weird one. Let's check the list. Yep, 83 is on the list of a prime number, so the only factors are 1 and 83. So we know it's prime. A negative number, too small. It's not prime, not composite because it's negative. So we say it's neither. 5. The only factors of 5 are 1 and 5, so we know it's prime. 1, too small. So we know it's going to be neither. So 0 and 1 are too small. They're not prime and not composite, so we say it's neither.